Welcome back, everyone. In this lesson, we want to go ahead and take a look at inheritance and subclasses, which is a very important topic, of course. Python's object orientation model does allow for inheritance, of course, as an advanced programming language. So let's go ahead and take a look at these. So I'm going to put in some note, inheritance and subclasses. So inheritance allows attributes and methods to be inherited. Let me be careful and say from parents, and that could be multiple parents. We can override the parent classes and subclasses. We can also add additional functionality. Let's take a look at creating a subclass, creating a new inherited class. So I'm going to create a class called developer. And the way you tell that this is inheriting from something else is to put what it's inheriting from inside the parentheses. And in this particular case, I don't want this to do really anything. So I'm just going to put pass here. And I've just created a subclass. Let's go ahead and create a dev1. Oops, not sure how that happened. But I think I covered that in a previous video that sometimes that happens. So dev_1 is equal to developer, and I'm going to pass to it Bugs Bunny with 100,000. Notice the developer has nothing in it, it just says pass, but because it's inheriting from employee, this is going to call the parent class's constructor, and Bugs Bunny should be created with no problem. So I'm going to print dev_1 dot full name, which is a method built into the parent class, and dev_1 dot pay, and let's also put in the email. So there we go. Beautiful. So we know we can actually inherit, which is great. Let's see if we can take a look at some of the resolution order of the method. So I'm going to use the help to show the method resolution order. So I'm going to print help with developer. And we get this. As you can see that this is going to initially look inside of developer to see what it can do to resolve a call, such as, full name. If it's not in developer, it's going to look into its parent, which is employee, and from there it's going to go to the generic parent to everything, which is the built-in objects right here. Methods inherited from employee, the delete method, the init method, apply race, full name are inherited. Static methods or class methods inherited are from string, set raise amount. Static methods inherited is workday. And we can see that we have data descriptors also inherited. Data and other attributes, number of employees, and raise amount. This help is fantastic, as you can see. It really does a wonderful job clarifying things for you. Let's say that we want developers, let me make it a capital D so we are clear, to have a 10% raise. So remember, the regular employees were getting a 4% raise. Let's take a look at that and just make sure of it. You can see that the raise amount was 4%. It was a class variable inside of employee. But I want my developers to be different. I want them to be treated with kid gloves, and I want them to get more pay. So I can go into employee, I can create it so it's inheriting from employee, but I'm going to change the class variable raise amount to be 1.10. And that's it, no more, no other changes. Let's go ahead and create a dev1 to be equal to developer Bugs Bunny with a pay of 100,000. We'll also create an emp one, and this will be an employee, Daffy Duck, with 100,000. Both are created. Now I'm going to apply the apply raise method. Now keep in mind that we did not discuss any apply raise in here. The apply raise is in the parent class, which is employee. If you recall, the apply raise method takes the pay, the current pay, and multiplies it by the raise amount. Now recall that we just made a change that developers get a 10% raise. So if I do dev_1 dot apply raise and then do emp_1 dot apply raise, do a shift enter, let's print both of these. So developer 1, which is Bugs Bunny's pay, and employee 1, which is Daffy Duck. You notice that the Bugs Bunny one went up by 10% as expected, and Daffy's went up by 4%. So we can do inheritance and we can override the parent's specifics. In this case, it was a class variable. We can override other things as well. Let's take a look at that. So I want to, let's say we want to pass the main programming language of the developer as a parameter. Okay. So I'm going to recreate class developer, inherits from employee. The raise amount, I'll leave it as 10%. I'm going to override the init method, which takes self first, last, and pay, and I'm going to add a programming language. Now, what I can do over here is I can say, you know what, for the first, last, and pay, which is from the parent, I don't want any changes. And the way I do that is using the super keyword. So I'm going to say super dot double underscore init double underscore first, last, and pay. Done. So the first, last, and pay will still be handled by the employee class. However, I'm going to let self.proglang, the programming language, to be equal to the programming language that was passed in the parameter. Now let's take a look and see how this works. I am going to copy and paste this developer 1 and employee 1. I'm going to add, for Bugs Bunny, a language of Python. Great. If I were to print dev_1 dot full name and dev_1 dot, let's say, email, and dev_1 dot programming language, you can see that Python is in fact listed. So just very cool. And you can see, if you're coming from other languages such as Java, that this is so elegant and so straightforward to work with. Let's go ahead and create managers. So I'm going to create a class called manager, which inherits from employee. I'm going to let managers raise amount be also 10%, so they don't get pissy with the developers. I'm going to use the def double underscore init double underscore, and we have our self keyword first, last, pay, and something else. Employees equals none. In other words, who does the manager supervises? And right now, by default, we're going to say the manager doesn't supervise anybody. In order to handle the first name, last name, and pay, I'm going to again call the super keyword a constructor, and the double underscore init, double underscore. And what do you want the super to handle? I want it to handle first name, last name, and pay. So we're done with the init at that point for that part of it. Now I'm going to have a conditional if employees is equal to none. So nothing was passed. That's the default value. Self.employees be equal to an empty list. Else, I'm going to let self.employees be equal to the employees list that was passed. So again, recall that the employees over here with a self in front of it is the instance variable, and this is the parameter, the values that we're passing to it. Okay? I want to have another method here. This is for manager, which is inheriting from employee. I'm going to have an add employee method. So we can add an employee to the manager if we want to. Take self and an employee. So let's keep going. I'm going to say if employee is not in self.employees, so we don't duplicate employees. So check if it's not self.employees dot append. It is a list, so we can call the append method and add the employee. That takes care of that. I would like to also be able to remove employees, so I'm going to create a remove employee, which takes self and an employee. If employee is in self.employees, the list, okay, and this is referring to the employees variable, the instance variable. If it's there, we're going to call self.employees, which is calling the list, and we're going to call the remove method and remove the employee. Finally, I would like to be able to see these employees. So I'm going to have a print employee, or let's call it employee so it's better. And for employee in self.employees, the list, print, let's say, little arrow here, employee dot full name and employee dot email. Okay, let's do a shift enter. Hopefully I don't have any errors. Now let's actually check this out. Let's see what this does for us. So I'm going to create a dev1, which I'll leave to be Bugs Bunny. Developer Bugs Bunny, $100,000. Language Python. Dev2 is developer Marvin Martian. Let's say $80,000, and he does C++. Employee 1 is employee Charlie Dog, gets 70,000. And let's create a manager. mgr1 is equal to, we're going to call the manager constructor, Porky Pig. And keep in mind that this one takes a pay also, let's say 90,000, and he is managing dev1, dev2, and emp1. Let's take a look at manager. I'm gonna do mgr1.email. Well, it looks like it actually created Porky's email for us, which is very cool. Let's take manager1 and call print employees. And there they are. You know what, I probably would have been good to put something in between, but that's okay. So I can see there's Bugs Bunny with his email and Marvin Martian with his email, etc., which is really, really nice. Let's create some more developers. So I'm going to have dev3 is developer Daffy Duck. Whoops. Daffy gets 80,000 and he works in Java. Developer 4, developer Pete Puma. Pete also gets 80,000 and he does Ada. Employee 2 is employee Bianca Mouse, and Bianca gets 90,000, and employee 3 is employee Bernard Mouse with 90,000. So I'm creating a bunch of employees. I want to be able to add these to the manager. I have manager 1, so I have mgr_1. I can call the add employee method and add developer 3. I can do mgr1.addEmployee developer 4, mgr1.addEmployee emp2, and mgr1.addEmployee emp3. Let's see if in fact this works. So mgr1.print employees. All of them were added. Just great. I want to go ahead and remove developer 3, which is Daffy Duck. We can see that Daffy is in here right now. So I'm going to come over here and say mgr1.remove employee developer 3. Okay, let's do mgr1.print employees, and we see that Daffy was in fact removed. Let me go ahead and see if I can add a repeated employee in there. I know I have developer 1, which is Bugs Bunny. Let's verify that. dev1 dot full name. That's Bugs Bunny. Can I add Bugs Bunny in there again? So I'm going to add employee dev_1. Well, let's take mgr_1.print employees. You notice he was not added to the list because we had that conditional where we're checking to see if the employee is not in there, then go ahead and add it. Otherwise, it would not bother adding it. And of course, if we want to remove an employee, it has to be in there first. If I try to remove something that's not there, it's just not going to work, which is very cool. Okay, I wanted to have covered all this. It's probably a good idea to go a little bit further. I know the video is getting a little long, but bear with me. I want to do a couple of other things. Some that might come in handy. Let's take a look at 2 built-in functions for working with classes. So these 2 are isInstance and isSubclass. Could come in very handy. I'm going to do a print, and I'm going to say isInstance manager1 an employee. So I'm asking, is manager 1 an instance of employee? And it says it's true, which it is. Now we know that manager 1 is really an instance of manager, but manager relies on employee. Let's go ahead and take a look at doing is instance manager 1 of developer. Now remember, developer is inheriting from employee, but it's a separate branch of employees. So we have managers and we have developers. This should return false, and it does. Okay, let's print is subclass manager 1 of employee. So you might have expected to get a true statement right here, but this is not what we get. What this is doing, this is saying is manager 1, which is an instance of manager. Is that a subclass of employee? Well, it's not. Clearly, it doesn't make any sense. It's an instance. What I really need to do is to say print is subclass manager of employee. So this is the correct statement, correct way of writing it. And you can see it says it's true, as expected. If I were to do print is subclass developer of manager, it's false because they're not they're sort of sisters. They're not subclasses of one another. All right, so this is all I wanted to cover here. I hope you enjoyed this. It's really getting to be more advanced stuff. Thanks for being a great audience. If you're liking these videos, please share them with loved ones and friends. Spread the word, and I'll see you in the next one.